When you hear the name F degrees Eth1/4 F degrees Eth1/2 and tilde Eth cedilla Eth1/2, which translates to manatee, you probably don't imagine speed, power, or military capability. But in 2025, the F degrees Eth1/4 F degrees Eth1/2 and tilde Eth cedilla Eth1/2 helicopter concept is generating serious attention in aviation circles. Beneath that calm, almost gentle name lies a heavy-duty rotary wing platform designed to play a major role in next-generation naval and transport operations. The 2025 update surrounding the F degrees Eth1/4 F degrees Eth1/2 and tilde Eth cedilla Eth1/2 focus on modernization, modularity, and mission flexibility. Unlike traditional helicopters that are locked into one primary role, this aircraft is being positioned as a multi-role heavy platform. That means it can shift between transport, maritime patrol, search and rescue, logistics support, and potentially anti-submarine operations depending on configuration. Let's start with its size and design philosophy. The F degrees Eth1/4 F degrees Eth1/2 and tilde Eth cedilla Eth1/2 is expected to fall into the heavy helicopter category. This means a large fuselage, high internal volume, and reinforced structural components. A helicopter in this class isn't built for agility like a lightweight scout aircraft, it's built for lifting power and operational endurance. The wide-body design allows it to carry a significant number of fully equipped personnel or multiple tons of cargo in a single mission. In real-world operations, that matters a lot. Fewer trips mean lower exposure in contested environments and greater efficiency in logistics-heavy missions. Whether it's transporting troops to offshore platforms, supplying remote bases, or supporting naval fleets, lift capacity defines operational impact. The 2025 direction also suggests improvements in engine performance. Heavy helicopters demand powerful turboshaft engines capable of delivering high torque while maintaining fuel efficiency. Modern engine upgrades focus on better fuel burn rates, increased reliability, and improved performance in harsh climates. Hot and high environments meaning high temperatures and high altitudes can significantly reduce lift capability. Engine refinements in 2025 aim to counter those limitations. Another critical area of improvement is avionics. Modern helicopters rely heavily on digital integration. The F degrees Eth1/4 F degrees Eth1/2 and tilde Eth cedilla Eth1/2 is expected to feature advanced glass cockpit systems, replacing traditional analog gauges with multi-function displays. These systems provide real-time flight data, navigation mapping, engine diagnostics, and mission information in one streamlined interface. This shift dramatically reduces pilot workload. Maritime operations, especially over open water or during poor visibility, are extremely demanding. Automated flight stabilization, digital autopilot systems, and enhanced navigation tools improve safety and mission precision. Speaking of maritime operations, the F degrees Eth1/4 F degrees Eth1/2 and tilde Eth cedilla Eth1/2 is closely associated with naval deployment scenarios. That means the design must account for saltwater corrosion, deck landings, and compact storage aboard ships. Special coatings, corrosion-resistant materials, and reinforced landing gear are essential for long-term durability in naval environments. Rotor blade folding mechanisms are another likely feature. Naval helicopters often need compact storage to fit into hangars on ships. Folding rotor systems allow a large aircraft to reduce its footprint without sacrificing operational capability. Noise and vibration management also play an important role in 2025 improvements. Heavy helicopters traditionally produce significant vibration due to rotor dynamics and transmission systems. Modern engineering focuses on refined rotor blade geometry, vibration dampening technologies, and smoother transmission systems. This not only improves crew comfort but enhances mission endurance and reduces long-term structural fatigue. If configured for anti-submarine warfare, the F degrees Eth1/4 F degrees Eth1/2 and tilde Eth cedilla Eth1/2's large frame becomes a major advantage. It can carry sonar systems, radar equipment, and additional operators without compromising fuel range. Space inside the cabin allows installation of specialized consoles and equipment tracks. This transforms the helicopter into a versatile maritime surveillance platform. Range is another strong point for helicopters in this class. With large internal fuel tanks and the possibility of auxiliary fuel systems, the F degrees F1/4 F degrees F1/2 and tilde F Sedilla F1/2 can operate far from base. That capability supports extended patrol missions and fleet escort operations. Cargo versatility is where the platform truly shines. The internal cabin could be configured for troop seating, cargo pallets, medical evacuation stretchers, or mission-specific modules. Quick reconfiguration systems allow operators to switch roles efficiently. This adaptability reduces the need for multiple specialized aircraft types. The 2025 focus on survivability cannot be ignored either. Modern helicopters operating in high-risk zones require defensive systems. This may include infrared countermeasure systems, radar warning receivers, and reinforced structures designed to withstand small arms fire. Survivability upgrades enhance confidence during operations in contested regions. Materials technology has also advanced. Composite components reduce weight while maintaining strength. Lighter airframes increase payload efficiency and improve fuel economy. In heavy helicopters, every kilogram saved contributes directly to operational effectiveness. Maintenance and reliability are equally important. In 2025 standards, predictive maintenance systems using onboard diagnostics can monitor engine performance, transmission health, and rotor condition in real time. This data-driven approach minimizes downtime and prevents unexpected failures. Another key factor is interoperability. Modern military and naval platforms must communicate seamlessly with ships, ground stations, and other aircraft. Secure communication systems and data link capabilities allow real-time information sharing. This turns the F degrees F1/4 F degrees F1/2 and tilde F Sedilla F1/2 into a connected asset rather than an isolated machine. Let's talk about the landing gear. Heavy helicopters designed for naval use require reinforced landing systems capable of handling deck motion. Ships at sea are constantly moving. A helicopter must land safely on a shifting surface. Stabilized landing gear and deck lock systems improve operational safety in rough conditions. Environmental adaptability is also critical. The F degrees F1/4 F degrees F1/2 and tilde F Sedilla F1/2 must operate in extreme cold, heat, humidity, and maritime climates. Enhanced filtration systems protect engines from salt and debris. Climate control systems maintain internal cabin comfort for crew and passengers during long missions. Fuel efficiency improvements in 2025 are not just about saving costs. They extend operational range and reduce logistical dependency. Fewer refueling stops mean longer patrol times and greater mission autonomy. Training integration is another modern element. Advanced simulation compatibility allows pilots to train using realistic digital environments that replicate the F degrees F1/4 F degrees F1/2 and tilde F Sedilla F1/2 systems. This reduces training costs and improves readiness before live operations. Safety features such as automated emergency landing systems, terrain awareness alerts, and enhanced weather radar improve operational security. In maritime environments, rapid weather changes are common. Advanced sensors provide early warning of hazardous conditions. From a strategic perspective, heavy helicopters like the F degrees F1/4 F degrees F1/2 and tilde F Sedilla F1/2 serve as force multipliers. They bridge the gap between ships and land bases, transport essential supplies, and extend the operational reach of naval fleets. The interior design also reflects modern ergonomic considerations. Crew stations are arranged for efficiency. Noise insulation improves communication clarity. Lighting systems support night operations without compromising external visibility. Another potential upgrade area is unmanned integration. While primarily crewed, Modern helicopter concepts often include partial automation or remote support capabilities. Data integration with drones or unmanned surface vessels enhances surveillance and coordination. Performance expectations suggest balanced speed and stability. Heavy helicopters prioritize lift and endurance over high-speed agility. However, aerodynamic refinements in 2025 may provide improved cruise efficiency and reduced drag. Rescue operations are another possible role. The spacious cabin allows installation of medical equipment and rescue hoists. In disaster relief scenarios, a heavy helicopter can deliver supplies and evacuate civilians efficiently. Structural reinforcement is essential for long service life. Fatigue-resistant materials and improved stress distribution extend operational longevity. This reduces life cycle costs and increases fleet reliability. Looking at global trends, heavy helicopters are becoming increasingly important in maritime strategy. Nations investing in naval expansion require reliable air support platforms. The F degrees F1/4 F degrees F1/2 and tilde F Sedilla F1/2 fits into that strategic framework. The transmission system, often overlooked, is a core component of helicopter performance. Improved gear materials and lubrication systems enhance reliability under heavy loads. Smooth power transfer from engines to rotors ensures stable lift generation. Digital diagnostics also allow ground crews to access performance logs quickly. Maintenance crews can identify issues before they escalate. This predictive approach aligns with modern aviation standards. If export markets become a consideration, modular configuration will be critical. Different operators may require customized mission packages. A flexible platform increases global appeal. In terms of aesthetics, heavy helicopters emphasize practicality over sleekness. The F degrees F1/4 F degrees F1/2 and tilde F Sedilla F1/2's design likely reflects functionality first. Wide fuselage, robust landing gear, and large rotor assembly define its visual identity. As we move further into 2025, the conversation around this helicopter continues to evolve. Whether fully operational or still in advanced development stages, the concept represents a push toward adaptable, durable, and technologically advanced rotary wing platforms. Heavy helicopters do not dominate headlines the way fighter jets do, but they quietly define operational capability behind the scenes. Transport, logistics, maritime patrol, and emergency response rely heavily on this class of aircraft. The F degrees F1/4 F degrees F1/2 and tilde F Sedilla F1/2 embodies that philosophy. A machine built for endurance rather than flash. A platform designed to serve multiple missions without compromise. A helicopter that prioritizes strength, flexibility, and reliability. In a world where naval strategy and rapid deployment matter more than ever, heavy rotary platforms play a central role. The 2025 updates suggest a focus on modernization, digital integration, improved engines, and mission adaptability. And while the name might sound gentle, the capabilities behind it tell a different story. The F degrees F1/4 F degrees F1/2 and tilde F Sedilla F1/2 helicopter stands as a symbol of practical power, not loud, not flashy, but undeniably capable. As development progresses and more official details emerge, the aviation community will be watching closely. Heavy lift helicopters may not always grab attention, but when missions demand strength and versatility, they are the aircraft that answer the call. That's the 2025 F degrees F1/4 F degrees F1/2 and tilde F Sedilla F1/2 helicopter, a heavy-duty, multi-role platform shaping the next chapter of rotary aviation.